meta-analysis with a binary outcome based on an effect size estimate, which is a risk ratio in R statistics, to generate a forest plot and a funnel plot. So what is a binary outcome? A binary outcome is a variable that have two levels in it, such as agree, disagree, live or dead, smoke, doesn't smoke. So this variable is dichotomous or binomial, as it only have two categories in it. The risk ratio is the ratio of the probability of an event occurring in one group, which is a treatment group or intervention group or exposure group, compared to the probability of this events, similar events happening in the control or reference or unexposed group. So it is the risk or the ratio of the risk of an event in one group relative to the risk in a control group. So what is meta-analysis? Meta-analysis is a statistical method that combine and collect data extracted from several independent clinical research or medical studies that addresses the same scientific or medical or clinical research question. The objective of the meta-analysis is to pool the data from all those studies and generate an overall estimate of the effect size, in this case, which is the risk ratio. Estimate of this effect size in an intervention group relative to a control group. So the analysis will generate also other values, and it will also include in it another test which will look for heterogeneity among the studies by generating an I-squared value, which is represented in percentage, which reflect the degree of inconsistency or variability among the results from studies. If the I-squared equal to 0 indicates no heterogeneity among the results. If it is 100%, that indicates maximum heterogeneity among the results from the data. Also, from the meta-analysis, a forest plot is generated. So what is a forest plot? It is a diagram that consists of 3 sections that summarizes the output of the meta-analysis. One section describes the statistics of the studies, all studies, giving the number of events, the odds ratio, which is the effect size, the 95% confidence interval, and the percentage or weight percentage. And the second section which represent the diagrammatic reflection of the descriptive statistics or descriptive analysis, and the third part that shows the overall estimate of the effect size, which is in this case the risk ratio, in addition to the test for the heterogeneity with I-squared value and the p-value. From also the outcome of meta-analysis, a funnel plot can be generated. The objective of the funnel plot is to examine and assess the application. The plot is a scattered plot that has on the y-axis the estimates of the effect size, which is the risk ratio, and on the y-axis is the standard error or sample size, and the plot is in a shape of a funnel. To perform meta-analysis in R statistics for a binary outcome based on the risk ratio, first of all, import the file that contains the data from the studies. And the way to do that is to click on File, scroll down to Import Data Set, and since the data stored in a SPSS format, select the that option, and then click on browse, select the file, and then click open, and then click on import. The data is imported into the R statistics, and as shown here, this is a table that shows data taken from 12 study, clinical data for each study for a experimental intervention or treatment. So the participant in this study has been recruited and arranged into two groups: the treatment group or the experimental group or the intervention group, and the control group. And as we can see here, there are 12 independent studies addressing specific question, and this column shows that the experimental events were counted for each group in each study, and the total number of participants for the experimental group is counted, and the same thing for the control or the reference group, in which the occurrence of the event is counted, and the total number of participants in the control group is also recorded here. So each study was designed to have two separate groups. One is experimental or exposure, and the other one is the control, and the events in each group is counted and recorded. So here we have an outcome that is binary, whether the events occur or it doesn't occur. So it is a dichotomous binomial outcome, and the risk ratio could be calculated and used to estimate the effect size. So to do a meta-analysis on this data based on a risk ratio for a binary outcome, first install the meta-analysis package. I've already installed the package, so I'm going to type here at this section library to load the meta package. Hit enter, and the package is installed or loaded into the R. And to do a meta-analysis, I will use the command metabin for binary. And first of all, let's generate an object and call it X and use the assignment operator. Then type the function for meta-analysis, meta binary, hit enter. Then a bracket will be opened. Inside that bracket, insert the data, which is as here being loaded, which is called the RR event meta-analysis. Copy and paste that in here section, then insert comma, and then after that insert the first event in the experimental group, followed by the total in the experimental group, and then followed by the event in the control group, followed by the total in the control group. So we'll type here the event in the experimental or exposure group is T capital, as the R is case sensitive, and event for the first set of data or variable. Then the next one is the total, T for total, comma, and then select the one which is stands for capital letter C underscore, and then event, comma, and then capital letter underscore total, and then insert comma. So to double check, so we select this variable as it has the event in it, and then we select the total number for the experimental or exposure group, and then for control group the event for the control and the total for the control. Then for the meta-analysis, we could use a random effects model or fixed effect model. I'm going to stick with the random effect model, so type random, then equal sign, and then type T for true. And for the fixed model, I'm going to type false. So if I want to have to calculate the meta-analysis based on random effect model, write that in this format: T for random, F for fixed. If I want to reverse that situation in which I want a fixed effect model, then a fixed will be true for T and random F for failure. Insert comma and then choose the method to use for the analysis. So type method and then equal sign, and I'm going to stick with the MH method for Mantel-Haenszel method, then comma, and then for the summary type SM and then quotation mark, and since we are using the risk ratio type RR, and then insert a comma and then insert also the label for the studies by typing study, put the cursor here and type study lab, which is study labels, and then the study label will be the variable which is here, the capital letter study ID, and then hit enter. So the command for the metabin for meta-analysis will use the data that we imported that has the events in it for the two groups, the control and the exposure, and then the event from the experimental and the total, the event from the control with the total, and random model, and method is MH, and the effect size is the risk ratio, and the study ID is also added. If I type X to view the output as shown here, a meta-analysis is performed but not yet forest plot and funnel plot produced. So the output shows that the number of studies, K equal 12 studies, the number of observation 1348, and the number of event 429. Also, as shown here, the random effect model is considered and used, and the risk ratio is generated, which is 2.34, and a 95% confidence interval, and a p-value. And also a heterogeneity test is performed based on two statistics. The tau squared is generated with 95% confidence interval, and an I squared also generated, which shows that 22.3%, and that is a value represent the degree of heterogeneity among the results with a 95% confidence interval. And a test of heterogeneity performed based on the Q statistics, which is based on the chi-square and the degree of freedom of 11 and a p-value of greater than 0.05. So from this data here, it shows that there is low level of heterogeneity among the 12 studies, as the I squared was 22.3 and the p-value to be greater than 0.05. From this meta-analysis, as shown here, that there is a higher risk ratio, which is 2.3 when we compare the exposure to the control. So this is the objective of doing meta-analysis, is to calculate the overall risk ratio rather than individual risk ratio for each individual study, and the overall is 2.34. The next step is to generate a forest plot. And the way to generate a forest plot, let's clean this. Either I use already pre-installed format, or I can use a basic format and then modify the structure and edit the forest plot. So if I type forest and type forest, open up brackets, put the name X, and then I could use a pre-installed format, which is by typing layout equal to, and then select the revman format. And if I click on enter, straight away forest plot is generated, and as shown here, this is in the format of a revman. There is three sections. The first section is descriptive statistics, the diagrammatic representation of this descriptive statistics, and the overall effect size, which is the overall RR. And as shown here, there is a section column for the studies from 1 to 12, the experimental and the control, the events, the total for each section, the weight percentage, which reflects the size of each individual study, as each study contribution to the overall analysis is weighted and given in percentage. Higher percentage indicates larger sample size. The MH method is used, with the risk ratio is calculated for each individual study with a 95% confidence interval with a lower and upper limit. And the second section, which is diagrammatic representation of the descriptive statistics. The overall or pooled risk ratio is given, which is 2.34 with 95% confidence interval. And the third section is that section that include the overall estimate and the heterogeneity test. We could also go back again and draw the forest and edit it in the certain style you wish to present. If we close the plot, and in the command section type forest X and hit enter, that will give me the basic structure for the forest plot. And as shown in the forest plot here, there is a missing value for the events, and we need to add this. And also I could do some changes in the coloring of these diagrammatic representation for the color of the squares and the color of the diamond, and for also the color of the line which represent the overall effect size or overall risk ratio. So to start with this, we add the pooled event for experimental and control. Back to the command section here, type forest, open up brackets X, and then type pooled dot events, hit enter, and then type T for true and hit enter again. And let's bring the graph or the plot, and as shown here, the total number of events for the experimental and control is given. To change the color of the squares, just type forest, or let's select the previous command here and then paste here. And for changing the color of the squares, insert comma and then type COL for color square and use the first function, and between two quotation let's make it red, and then hit enter, and then bring the plot as shown here. The squares are color coded red. To change the color for the diamond, which is by the way, this is a specific risk ratio for each individual study, and this one is for the overall. To change the color of the diamond, back again to the command section, copy the previous command, insert it here, then insert a comma, and then type COL dot diamond and select the function for diamond, and in between two quotation, let's make it here green. If we type green and then hit enter and bring the plot as shown here, the diamond is color coded green. And to change the dotted line here into blue, again copy the command, place it here, and then after the comma type call dot, since we used the random models, select that equal sign and then quotation mark, and let's make it blue in color. Hit enter, click on zoom, and as shown here, the dotted line is blue in color. So this is the way to generate a forest plot. So this forest plot will summarize the meta-analysis for all the 12 studies, and as shown here, there are a risk ratio calculated for each individual study and an overall risk ratio from the 12 studies for comparison, and the squares here represent the risk ratio for each individual study, and the size differences is reflection of the size of the sample or the weighted percentage. Higher sample size have higher square. The horizontal line represents the 95% confidence interval, and the vertical line, dashed line, is the line for the overall risk ratio, and the diamond, as I said, is for the overall representation of the overall risk ratio. And the section here gives the heterogeneity test for I-squared and a p-value. And from this meta-analysis, a comparison has been generated between the experimental to control, and overall value is generated, which is 2.34, and this value is significant as shown by the 95% confidence interval. We could also generate another plot, which is the funnel plot, and the objective of the funnel plot is to assess bias in publication. And the way to do the funnel plot is just type funnel, open a bracket, and put the x value, which is the object, and a funnel plot is drawn as shown here. The funnel plot has on the x-axis is the risk ratio for each individual separate study, and for the y-axis is the standard error. We could select also sample size if you wish, and this is a scattered plot in a form of a funnel, and the line in the middle is the pooled or overall risk ratio, which is 2.4, around 2.4, and the small circles here are the individual risk ratio for each study. For the lack of bias, no bias in publication, the distribution of the effect size or the RR for each individual study should be equally distributed on both sections here, above and below the line, which is the overall risk ratio. And here we have 1, 2, 3, 4, 5, 6, 7, 8 studies with a risk ratio on the right side and 3 on the left and 1 outside the funnel. There is a bias in publication, and an additional test needed to be done to confirm and supplement the finding, which is the Eagers regression test. So this is the way to perform meta-analysis for an outcome that is binary based on risk ratio in R statistics, and generate a forest plot and a funnel plot.